So this is another video on the surface geometry topic. So this time we're going through transition pieces. So here we have an oblique transition piece going from a rectangular to a square, but it's also oblique. So I thought that this was a similar question that was posted in the book, and I decided that it would be better to draw the question up on AutoCAD to give the pupils a better understanding of where the points come from. And it also shows them how triangulation is working. So, as you can see here, we're breaking up these sides to try to find the true length of these sides using triangulation. So we can see that the length 1 to 6, so if you see this arc is rotated or down to the horizontal, brought back up to the XY line, and brought back to point 1. So that has given us the true length of the diagonal 1 to 6. So it'll be easy to explain to pupils how and where we're coming from. So then we can complete these also then for the other points. So as you can see here, point 8 is brought up to the horizontal the other way. So depending on what side of the shape the triangles are on, will change where the true lengths are coming from. So then we also need to find the true lengths of the cross section as well. So I've done two construction errors here. So what we could do is we turn off one construction error and turn back on this one. So this then would show how we can receive other points. So like for point 4 to 8 here, we can rotate that down, bring it back up to the XY line and back up to point 4 here. So that will give us these true lengths. So we can show that without overcomplicating drawing for the pupil, how we can show the different triangulation and the true lengths are found. So then we can see that bringing point 6 back up and say point 5 as well, they come back to their horizontal. So depending on where they are in the drawing, not to become confused, it depends on where you bring the drawing up. Then if we turn on all the layers, then we can see where these points are coming from, and they're all our true lengths. So then coming back, so if we move back in this development of the transition piece, we can see that the true lengths. So we can say, so we have our length here from point 1 to point 6, so 1 to 6 down here, which is the inside line here. So we can show, dimension. So we can just hover dimension over it. So I will just change that to type A first. Sorry, 1 second. So we can say click our dimension here and hover over. So that's giving us a dimension of 126.89. So if we go over here and then look around 1 to 6, hover over that, and then we can show the pupils. That's where our triangulation is. So we can start off because we know that the rectangle and the square are all true lengths because they're parallel to the horizontal plane and vertical plane, or sorry, parallel to the horizontal plane. So then we can show where these true lengths are coming from. So they're 126. So how we swing it from point 1 cross down here 126.89 millimeters. But pupils can step off this length using their compass, and then how we swing an arc 25 here from this horizontal to intersect here, and that's to give us 0.6. And then how we use, say, the length from 6 back to 3 is 110.38. So we're looking for 6.3. So this is this point here. So 0.6 rotated back up. So that's, you can see that that's a 106.83. So then I've also created a physical model for this question as well, because I feel like that the triangulation is a big new part of the topic that the pupils will be using. So I think a physical model also will help reinforce the properties.